Hey guys, welcome back to another Algebra 2 video. In this one, we're going to talk about how to graph quadratics or parabolas by factoring them. Now, if you watched my last video, it was about an hour-long video on just factoring and all kinds of different ways of doing that. And in the video, I kept alluding to the fact that we're doing this for a reason. There was a purpose behind it. And this is that purpose. We are going to use that tool of factoring to help us graph. So before we actually do that, let's talk about the motivation. Why would factoring help us? Well, before we do that, we need to learn or remind ourselves what a quadratic actually looks like. Let's look at the original quadratic parent function. That's just y equals x squared. If I were to graph that, it would look like this. I've got my dots here. I'm trying to draw my curves. So this is the basic parabola, right? And before, in a previous video on parent functions and translating them, we learned how to move this thing around. So if I did, say, x plus 2 squared minus 3, that meant my new vertex is negative 2, negative 3. And so really what I did was I just took the shape that was already there and I just moved it to negative 2, negative 3, like right there. I didn't change the graph. I just moved it to a different spot based on that new vertex. But the reason I could do that is because it looked like this, right? It was in this vertex form, right? But what if it's not in that vertex form? What if it's in a different form? How could we graph it? Well, one thing you might think might be, well, if you have a parabola, not all the time, but if you have a parabola that crosses the x-axis, like say here, notice this thing crosses at two different places. If it goes up here, it crosses two different places. Here, it crosses at one place. But if you could figure out how to find out where this thing crosses the x-axis, then you would have a really good method for graphing this thing, right? So for instance, I'll just go ahead and do one. If you happened to know that your parabola was going to cross here and here, then you could just remember the pattern and complete the picture, right? Because it's going to be down 3 and over 1 from this distance, and down 3 and over 1 from this distance, and then down 1 in that shape, right? Same thing with this. If I had, let's say I knew that my parabola was going to cross at these two places. If I knew that, well, taking these dots, let me actually show you how this works. The only way this configuration of dots lines up with that is if it's those two dots, right? And so then I could just fill in the rest of these dots. So the point is, if I know where it's going to cross the x-axis, here and here, if I know those places, then I can quite easily graph the parabola. All right? So let's see if we can figure out how to do that. Well, first of all, let's think about what happens when you do cross the x-axis. What does this mean? This point is negative 2, 0. The y is 0. Here is positive 2. Y is 0. Everywhere along the x-axis, this is what? 1, 2, 3, 4, 5, 6, 6, 0. Everywhere along the x-axis, your y value is always 0. That's the whole idea. That means that the height is 0. It hasn't gone up or down, right? So if I wanted to find out where my parabola has a height of 0, I'm going to literally make y equal 0. Let me give you an example. Let's say I have a parabola that looks like this. Let's see. Okay. All right, so this is my parabola. All right. Now this is not in vertex form, is it? So I can't just find the vertex really quick and then just graph it like I did in that other example, right? Let me get rid of this stuff so it's not confusing. So my goal is to find out where this thing is equal to 0. Well, remember, if you plug things in for x, the number that pops out is y. So whatever I plug into this equation, if I plug in a 2 or a 4 or whatever I plug in, the number that comes out of it when I calculate it is going to be y, right? That's why we put y equals the equation, because the equation equals whatever y value it is. Well, remember, I'm looking for something that has a height or a y value of 0. So I'm literally just going to make y 0. I'm going to demand that this equation has to be equal to 0. And what that forces is that any x that I plug in, if this is true, any x that I plug in is going to be one of these dots, right? Because I'm demanding the y value is already 0, so it's already on this line. So that means whatever x satisfies this number, or this equation rather, is going to give me an x value. Is going to give me an x-axis number, or a x-intercept rather. Okay, so how do we do that? Well, let's solve this equation. One really easy way to solve this equation is to, you guessed it, factor it. So let's factor this thing. What multiplies to give me 8 but adds to give me 6? Well, positive 2 and positive 4. Now, I'm not really going to go through a lot of factoring examples, if any, after this one in this video, because I spent so much time in another video. That's not the purpose of this. But once you factor it and it's equal to 0, ask yourself, what numbers could I plug into here to make this true? Well, this is a number times another number. And that when you multiply those together, it has to equal 0. So ask yourself, if I have something times something else and the answer is 0, what does that mean? Has to happen. Well, what that means is this piece has to be 0 or this piece has to be 0, right? If this thing here was 0, then 0 times this thing is going to be 0, right? By the same token, if this thing was 0, 0 times this thing, whatever it is, would be what? 0. So the point is, I want either this to be 0 or this to be 0. Let's think about what would make that happen. What number could I plug in here to make that 0? Negative 2. And think about that for a second. Let's talk about the logic. Now, practically, you could just switch the sign and call it a day. I get that. But I want you to think about why we're doing this. If you put a negative 2 here, this is now a negative 2. Then negative 2 plus 2 is 0. So this piece is 0. This, negative 2 plus 4 is 2. But that doesn't really matter because 0 times 2 is 0, and that equals 0. So it works. So what that means is, if I plug in a negative 2, let me get rid of that. If I plug in a negative 2, I get a height of 0, which means negative 2 is my x-intercept. I keep saying x-intercept. I'm going to go ahead and tell you the real thing we call this. This is called a root, or a 0. I'm going to call a root. So this is a root. All right. There's another root, because just as easily, I could put a negative 4 here, right? So if I put in a negative 4 right here, negative 4 plus 4 gives me 0. And if I plug negative 4 over here, 2 minus 4 is negative 2. It doesn't matter, though. Point is, 0 times anything is 0. This is 0. So if I put a negative 4 into that x, then I get 0 as well, which means what? This is also a root. So I have 2 roots. Okay? So I just went through the logic of that, like why we do it. If you're uncomfortable with that, just realize that really all I did was I factored it and I switched the 2 signs and I plotted them on the x-axis. That's literally all I did. But I do want you to try to understand why we're doing this and the concept behind it. Okay, so now let's graph this thing. Now to show you how this works, I kind of alluded to it earlier. Let me use a different color. Let's use blue. I'm just going to come down here and as scratch work, I'm just going to graph the parabola that I already know how to do. I already know what the parabola looks like, right? How could I make this parabola shape fit with those 2 dots? Well, if I slide it up here, it doesn't fit here because that's too far apart, right? But here, those dots are too wide, just like the ones that I've got on my x-axis, right? See that? So because these line up, it means it's that set of dots. So that means that my graph is going to look like this. I'll go ahead and draw over just to reiterate. And that's my parabola. Just like that. Okay? Really that simple. So just to recap, we factor, we switch the signs, we put them on the x-axis, and we draw u. That's it. All right, let's do another one. Let's see. Let's go with that. And sorry, I have to make these up off the top of my head. Okay, that should work. All right, I suggest pausing the video, trying it, see if you can graph it, and then come back and I'll work through it for you. All right, so the idea is we're going to demand that this is equal to 0, which means I'm looking for x-intercepts or roots. How do I do that? Well, if I factor it, then I get what multiplies to give me 5, it adds to give me negative 6. That's negative 5 and negative 1. All right, still equal to 0, right? Now, how do I make this true? How do I make this equation equal to 0? Well, by realizing that a 5 would make this 0 or a 1. Okay, now I put these in a list with a comma. Please do not do this. This means coordinate. That's very different. That is wrong. Okay, I see a lot of students do that. They get confused about what's actually happening here. We're just making a list of 2 points or 2 roots. And these are points on the x-axis. Oh, did I write that on the wrong one? I did. There it is. That's 1 and 5. All right. So just like before, I'm going to think about how does this line up with my basic parent function parabola? Well, if I notice the middle is here, right? This is a distance of 2. And I know that the distance of 2 is going to be 4 away from the vertex. There's all kinds of ways you can think about it, but just think about memorizing the shape and making the shape fit whatever distance you have between your 2 roots. And there we go. All right. Let's do another one. What if you had something like this? Now, I'm going to stop factoring things. I'm just going to go ahead and give you the factored version because, again, I have another video on that stuff. So let's just skip the factoring part if that's okay, and jump straight to the graphing part. Let's do x plus 1 and x minus 3, and let's make this negative out front. So let's assume that you already factored it, which means at the beginning the negative was out front, the x squared, I had to pull it out, right? And then I had to factor this. And then I get to this, and I say, all right, well, my roots I know are negative 1 and positive 3. This negative up front doesn't change the fact that I still have to swap those numbers. It doesn't do anything to those roots. The roots are what they are. You still do the same things, negative 1 and 3. But what's different is, since that negative's up there, it means that this parabola is upside down. So you do the exact same thing as you did before, except now you're going to change your shape to look like this. Right? Same exact thing as last time, but now you flip it upside down. Okay, let's do another one. How about this one? Actually, you know what? I am going to factor this one out for you because I want you to see it, how it works. Okay, so you have this equation, this quadratic. Now this one, if you remember back to the factoring video, this is going to be a little bit different than the last one we did because you have an x in both of them, so you can pull an x out. So if I pull an x out, I'm going to have x plus 2. All right? And then I'm going to say I must make that 0. Well, it's easy to see that you could plug a -2 in here to make this 0, right? So that -2 there plus 2 is 0. So that's one of the roots. What could you plug into this one, though, to make it 0? It's almost too simple. It's actually just 0, right? It's like saying, how do you make that 0? Make it 0. You just put a 0 there. So you still have two roots. It's just that one of them is 0. So you go over here, 0, -2. You've memorized the shape, so you know where these dots go. So now you have something like that. Easy. So just remember, when you have an x by itself in the factored form, it means that you have a root of 0. Let's do another variation. Something else that you could see might be, well, you could see something like this. What if you factored and you ended up getting this? See that? Now, what would you plug into the first one? Well, you plug in 2. What do you plug in the second one? 2. Now, I've seen some students say, well, you can't do that. You can't have both 2, so maybe I just need to just make this one negative. No, don't do that. It literally just means 2. So really, the second one isn't even there. The only root you have is 2. Okay, what does that mean? Well, that's the only place this thing crosses the x-axis. Think about what the shape looked like, or what would it look like if it only touched one time. Well, if you have it below the x-axis like this, it touches twice. This doesn't touch at all. But if you put it right on it, and that's actually the vertex, then it touches once, right? That's how that works. So if you have two roots that are actually just the same number, so one root, it's just the vertex. That's what that looks like. And if it was a negative out front, what would you do? Flip it upside down. Okay. Let's see. Should we do any more of these? Let's do a couple more. Here, you try this one and see how you do. All right, I'm going to assume that you've tried it. Our roots are going to be 0 and -4. 0, -4. And this negative here means it's going to be upside down. So I go up here and graph this, and this, and this. Parabola. Easy. I hope this isn't complicated. I hope you're not, please don't make this more difficult than it is or overthink this. There's really not much going on. I talked a little bit about the theory behind why it works at the beginning, but again, practically, you're just changing the sign of a number, sticking dots on it, and drawing a U. Okay, so don't overcomplicate this. All right, there is one more thing I can show you, one more variation. What if you had something like one where you had to pull a 2 out first? Remember where we factored something, you pull a 2 out, and then you left that here and you factored it, and it becomes something like this, right? We did some of those in the last video where you pull something out. Well, let's do x minus, let's say, 4 and x minus 6. So you factored something, and it ended up being this. What does that 2 do? Well, the roots are still the same. Just like with the negative, it doesn't change them, right? So the root from here is 4, the root from here is 6. So I know that they go right here. But what does that 2 do? Well, if you remember back in our parent functions video, that 2 takes a parabola, or any function rather, and stretches it upward by a factor of 2. So to just graph the parent function, let me actually do that. This is the parent function. So you have 1 in the middle, and then instead of going over 1 and up 1 like this, that 2 multiplies that height by 2. In other words, it doubles every height. So it goes over 1 and up 2, and then over 2 and up 4. Right? No, normally it's 4. Now it's 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Right? So it takes the parabola and stretches it upward like that. Well, how would you line that up with the dots that we've been given? Like this. that means that if these cross here, then my parabola starts with a vertex a little bit lower. So now this is actually my vertex. Then I have my dots up here. Up. Then I can draw my parabola. And that's how that works. Okay. So it's actually pretty easy, I think, to graph these things if you know how to factor them. And also, if you haven't noticed, I've only been doing things that have roots that are 2 apart or 4 apart or right on the thing. And to be honest, that is kind of limited, right? You won't always have something work out nice and pretty like that. You might have an odd number of points between, things like that. Um, but I just wanted to introduce this concept to you by using some nice, easy to see pictures. In the next video, we're going to talk about how to find the vertices and roots and things when you can't factor it, or if you factor it and they're at some strange places, right? They're not evenly spaced like I've got them here. Okay, so this is, like I said, this is really useful if the formula or the equation is nice and pretty and factors easily. But in most cases, you're going to have to do a little bit more work to get that, and that's where we're going from here in the next couple of videos. All right, thanks for sticking with me, guys, and I'll see you guys in the next one.